Hello friends, welcome to today's episode of Problem of the Day series from Leetcode. Today we are going to solve the problem number 1416, restore the array. So let's take a look at the problem. A program was supposed to print an array of integers. Okay, we have an array of integers, and basically instead of printing the white spaces or comma, they just print it as it is. So that means that if my array contains say 1570, it just printed 1570. Now given the string s, so this is my string s, and we have been given integer k. So the k means that any integer in this whole array has to be less than or equal to k. So we have to find out the total number of possible arrays that can be printed as s. Basically how many arrays I can build using this, with a constraint that every number in that array is going to be less than or equal to k, right? So let's take an example. So for example, we had 1317. Okay, that means that I can write as like 13 and 17, or I can write 1317. Okay, so the numbers can also be duplicated. There are no constraints on that. So or we can just write down this whole number as 1317, and we have to find a total number of ways. Okay, this problem looks similar to something like combinations. So let's take a look at how should we approach this problem. So I had been given 1317. Okay, and this is a string s. Okay, so there are I so there are two ways I can look into this problem. First is that at any given index, for example, I am at this index. Now there are two possibilities, or I can handle this as in two different directions. First, this number is part of the previous number, so it could be 131. Okay, or this number is the start of a new number, so which could be 13 comma 1 and then 7, something like that in future. So that's the first way of looking into this problem. The second way is I can 1317. One way is that I can start exploring that all my numbers that are starting from 1. So like for example, I have 1, then 1 3, then 1 3 1, and then 1 3 1 7. Okay, then I can look at the number which are starting from, so once you have this portion, so I have, now I am exploring all the numbers which are starting from 1. Okay, so now after that we have this array. Now this can also be treated as, okay, now I can start with 3, and 3 can be treated as 3, then 3 and 1, and then 3 1 and 7. Okay, and similarly I can go and start looking into this way, that I can explore uh, 1 as, so once you got 1 and then you got 7, so that means that now you have reached. In this whole breaking down the problem, in this whole series, you have to make sure that every number they're building, like for example is 13 and 131 and 1317, they are actually less than or equal to k. Okay, so now let's formalize what we can do here. So what we can do is we can write down a function. Basically we write down a recursive function, say let's say recurse you have s and k, and I am going to start from index 0. Okay, So that means that I am going to get all the numbers, all possible ways starting from index 0. So my final answer is going to be this one. So in the actual definition of the function, it is going to be the index start. So start means that I am going to solve the problem. So this is start. That means that now this function recurse is going to return you the total number of ways the array can be printed starting from this index till the end of the array. So let's try to code this function. So as discussed, we are going to create a function, recursive function. Let's name the function as it is, and the only difference is that it is not going to look at the integer start index. Okay, now that means that I'm going to return this function passing with sk and 0. Okay, now let's implement this function. So at any moment when my start index actually reached till the length of the string, that means that you have found one solution, right? So now if start is equal to s dot length return 1, right? Now I mentioned that my string cannot have a leading zeros, right? It cannot have zeros. So that means that if my string s of start is equal to 0, right, that means that is going to be, it has to be the part of your previous start. So there is nothing much I can have to explore, you just return 0 from here, right? Now let's calculate the number of ways we can fulfill the requirement starting from this index start. So we're going to start for integer I is equal to start I is less than s dot length and plus plus I. Now so we had this value as a start, and this is where the I is going. So suppose this value is I. So now we have to take a look at this string and see if the number in this range is actually less than or equal to k or not. So that means that we'll get the substring first. Number str is equal to s dot substring. My start index is going to be start, and the length of the string will be I minus start plus 1, and convert it to a number. Integer number is equal to int dot parse num str, and if my number is greater than k, that is it is no longer possible and going forward does not make sense because number is going to keep on increasing. So we'll just break it from here, right? And then yeah, otherwise my, that means my number is less than k. Now let's evaluate the ways number of count for starting from this index onwards. So that is equal to count plus equal to number of arrays s comma k comma not the start, it's actually going to be I plus 1, and let's not forget the mod 1 2 3 3 2 3 0 0 7, right? And then you return the count. All right, let's run it again. Okay, so this is accepted, but the time complexity for this function is going to be pretty high because it's going to, maybe it is going to in some time somewhere in the polynomial. So if you submit, it's going to hit the TLE. Okay, it's going to be TLE. So let's fix that. Now if we take a look at our uh, approach that we had, where we are actually, so we started with this function start is equal to 0, and then in the whole loop we get this one, and then for every recursion function I am again doing for this, and you are again starting from here. So that means that we are actually solving a lot of duplicate problems. That means that for the same start I might be computing it multiple times. So one way of fixing this is like using memoization. So let's use the memoization to fix it. So we are going to create private integer array memo, which is equal to null, and then at the end memo is equal to new integer array of s dot length, right? This remains as it is, this remains as it is. Now here if I have already solved, that means if memo of start is not equal to 0, then you return memo of start, and then otherwise you are going to do memo of start is equal to count, and count, right? Ideally this should fix the problem, but what I found is that there is a lot of overflow is happening. So let me fix this case by changing it to this value to be long count, and this could also be long, and then we are going to do a lot of mods here. So instead of doing this, I'm going to do this, right? And then convert this to integer and run and submit. Runtime error, stack overflow. Okay, something is not correct here. Okay, it seems that, okay, my bad, it is long dot parse, and then submit. All right, that's good for today. We'll see you tomorrow. If you have liked this video, please like it and subscribe to our channel, and also let me also please share that how do you feel like about any suggestions for improving this video. Please let me know in the comments. Thank you.